So we're on page 16. And look at what we've got going on. My goodness. It says solve the system of inequalities. So now we've got 3 different equations, but they're actually inequalities, right? To not only graph, but also shade. And this is going to apply into the systems that we're going to talk about tomorrow, which are like real world things. But Bob, how would I graph x is greater than or equal to 0? Hoy or Vux, Bob?
Huh? Oh, Vux.
Okay, Vux. So what am I going to draw? A horizontal or a vertical line? Vertical line at 0. Bob, would I shade to the right or to the left if I'm going to be greater than 0?
Maybe to the right.
And if I were you guys, here's how I might do this right now. I might just draw myself some little arrows that are signifying I'm going to shade to the right. My reason being, instead of going like, woo, we're going to have a lot of shading going on. So this is going to kind of help dictate what the shape is going to be at the end. Okay, who's helping me with a y is greater than or equal to 0? Teo is back. What do you got, Teo? And where do I start it? At 0, he says. Horizontal line at 0. Hey, Mateo, if it's greater than or equal to 0, do I want to shade above or below? Greater. He's saying above. So I'm going to just kind of draw my little arrows that way. Cooper, help me.
You can turn that into y is less than and negative 2x plus 4.
Ooh, so many people forget to put the negative sign. Very good, sir. Then what do I do?
I believe you graphed it, though.
How would I do that?
You go up 4,
And then?
go up 2.
Oh.
No, you go down.
Down 2 in which direction? Left or right 1?
Right.
Very good. Down 2, right 1. Solid or dashed line?
Solid.
All of them are going to be solid because all of them were or equal to. With these systems that we're going to be dealing with, they're all going to be solid. So you guys, if we're less than my purple line, would I shade above, which is here, or would I shade below, which is here? Below. So you guys, I would be shading below this. So my question is, what's the region that would be colored in, i.e. where are all of my arrows pointing?
Right there.
That little triangle. That's a little bit more descriptive than right there.
Over there.
So here's the deal, you guys. Who can tell me a possible solution that's in this shaded region? Annabelle? Would you guys agree? 1, 1, boop, is a point in my shaded region. Yeah. Ritzy, give me a point that's not a solution.
4, 5.
4, 5. Ritz, what if I were to say 4, 0? Is that not a solution?
That would not be a solution.
Correct, because why?
Take into account every single equation.
Exactly. It's not in my shaded region. So you could have said 4, 5. You could have said, I'm sorry, you said 4, 5. Was that yours? 5, 5, whatever. What if I said this point, you guys, 2, 0?
Yes.
Yeah.
If all those lines are crossing.
Exactly. Now, it's in my region because they're all or equal to's, right? Perfect. Now, this is what's going to help us for tomorrow, you guys. The region is a triangle whose vertices are at what 3 points? This is what we're going to use tomorrow. It's asking for the vertices, and I'm going to put these in bright yellow. It needs this coordinate, and this coordinate. The 3 yellow coordinates that bound my triangle. Who could give me one of them? 0, 0 is one of them. What else? 2, 0, and 0, 4. So that's what we're doing today. We're not dealing with word problems with them yet, but we'll get there on Thursday. Let's go graph this guy. Help me out, you guys. How am I going to be able to graph this one?
You have to.
Y is less than or equal to positive x plus 2 because we added x to both sides. I dig it. How do I graph that, Beck?
You go to y like that, and then go up a right angle 1.
Rise what? Yeah. 1 over 1, he says. Solid or dash, Beck?
Solid.
Boom. Hey, Beck. You told me y is less than or equal to. Do you want me to shade in region 1 or 2 if I'm less than that line? Say it again. 2, agreed. So I'm just going to draw my little arrows that you wanted me to shade in this direction. Who's got y is greater than or equal to 0? Hoy or Vux? Hoy. Horizontal line at 0. I'm going to do this one in pink I've got to be greater than, so I'm going to shade above it. I'm going to just draw some arrows that say I'm going up. This one's a little funky. Don't be getting cocky on me, okay? Because this is going to be a little weird. What's going on here? Could I separate this out two different ways? That not only is my 0 less than or equal to x, I'm going to rewrite that as x is greater than or equal to 0. And what's the other one?
X is less than or equal to 5.
Bob, you got it. We need to go graph both of those. X equals, what will those lines look like? Vertical lines. Those are going to be vertical lines at 0 and 5. So I'm going to go over at 0, a vertical line at 0, and at 5. Well, let's look. You guys, if I've got to be greater than 0, am I going to the right? Very good, Coop. The right or the left of this 0 line? Greater than 0. To the right. So I've got to go to the right of that 0. What about my x is less than or equal to 5? Go to the left of 5. So we're like, okay, we're looking at this little region, this little quadrilateral as of right now. But then I'm about to rock your world with this last one. Get y by itself on that one. Y is less than or equal to, beautiful, Mateo. I'm going to go up 6. My slope is negative x, so I'm going to draw that the whole way down and to the right. They're all or equal to, so I'm making them all solid. Okay, this is the weirdest thing. Where's my region? What do I shade in? Do you agree it looks like it's here? And then we're going here. We got this little house. What's going on over here?
Got a little wall.
We got a little wall. We got this cute little house, and he was like blown down by the... Who blew down the houses in the Three Little Pigs? The wolf? The big bad wolf. He like blew over that roof a little bit, but you guys agree that there's that vertical line there. A wall. Thanks, Bob. Give me a possible solution that's in this big the little pig's house.
2-2.
2-2. I love 2-2. Not a solution? 7-7. What about 4-3?
What about 3-0?
4-3 is not. What about 4-2?
Yes.
Yeah, it's on the line. That's okay. So it's not a solution. What do we say? We're 7-7. Word, I'm fine with that. Okay. What are my vertices?
0-0.
0-0 says Bob.
0-2.
0-2 says Bob.
2-4.
2-4.
5-1.
5-0 and 5-1.
Ooh, Cooper tried to get in there for that chocolate. Now, look what it says. Find the max and the min values of this function. Again, this is really no context for today because we don't have a real world problem. But do you agree companies want to potentially maximize their profits?
Yes.
And companies are going to want to minimize their
Spending.
expenses, right? Or their losses, right? So they're going to have very complicated equations, and they're going to have all different scenarios, and they're going to try to figure out the best balance to maximize things or minimize other things. So this equation will always be given to you, okay, whatever the equation is. What your job is to go take those vertices that we found and plug them into the equation that they gave you. So all I've got to look at is I'm going to say, all right, what is f of 0, 0? I said that because this is saying f of xy. I'm going to use this first point. And all that means is I got to plug in a 0 for the x and a 0 for the y right here. Boop, boop. So do you guys agree that that would get me 5 times 0 minus 3 times 0? And we just have 0, right? Okay. Let's go do that with another point. Mateo, what if I use the point 0, 2? We got to go plug in 0 for the x and 2 for the y in that equation. Mateo, 0 for the x and 2 for the y. Any ideas what that's going to get me? Beautiful. Bigger or smaller than 0? So right now, that's going to be my min. My min is going to be at 0, 2. Okay. Let's do another one. Porter, you want to do that? What about f of 2, 4?
2, 4 would be 10 minus 12 to get -2.
Beautiful. Is that my new min?
No.
No, it's still small, but it's not the small list. Very good. Let's go check 5-0. 5 times 5 minus 3 times 0. Ooh, 25. Is that my new max? Yeah. How about 5, 1?
22.
5 times 5 minus 3 times 1, 22. So all I want you, if I were you, I would just say min next to the smallest value, max next to the biggest. Okay, I didn't record this page. I apologize. I'm going to just talk through what we've got. We got my y's by themselves. Make sure that you're flipping the sign. Flip the sign when you're dividing by a negative. So go ahead and pause the video and see if you can get all these equations. I went ahead and color-coded each equation and which way to shade. And I was left with this cute little kite. This kite has the following vertices. Again, just pause it to see if you can also get these vertices. And then we plugged those vertices into this equation. -2 for x, 0 for y, plus 2. Getting me a minimum of -1 and a maximum of 8. And the last problem, this is just a little review. When I shaded these, one above and one below, we would have no solution because there's no overlap. Homework is pages 18 and 19.